Hello class, today we're moving into section 10-4, radical equations is the topic for today. Basically all this means is we're going to be solving equations that involve radicals, okay? Should be just a minor step from where we were last time to what we're going to be doing today. Shouldn't be, I think, very hard for you to move forward in this section. You could almost figure it out on your own, I think. So in any event, let me do some problems for you to show you how we go about that. And just in case you missed the email, we are having church on Sabbath morning at 10:50 via Zoom. You should have received a link in your email. If not, let me know, but check your email and make sure you have that link. 10:50 Saturday morning for church if you would like to join us, and that'd be great if you did. I never did hear from any of you what you thought of last week's service. If it was something that you enjoyed or would like to see it continue, it'd be nice to hear from you. Give us some feedback. Okay, we'll be switching over now to our whiteboard so we can get started. Okay, so radical equations. I think the easiest way to go about this is just to show you examples. So we're going to start with our first example here. Okay, the equation we're going to be dealing with is the square root of 7x plus 2 is equal to, not equal to, plus 3 equals 7. Okay? Square root of 7x plus 2 plus 3 is equal to 7. So the first thing we do is to isolate, or the objective is to isolate the term that involves the variable. So you see the variable x is part of the radicand. So what we would want to accomplish then is to isolate the term that involves the variable. We want to isolate this radical, if you like. So we need to take the 3 to the other side, as we're accustomed to doing. Take that 3 to the other side. So here we go. We get the square root of 7x plus 2 is equal to 7 minus 3, or the square root of 7x plus 2, is equal to 4. Okay. Square root of 7x plus 2 is equal to 4. Now, when you get to this point, you can see here that the square root of 7x plus 2, this is the principal square root, so it should be a positive number. If we square this thing on both sides, what happens when you square a square root? What happens when you square a square root? So if I have something like this, if I have the square root of 9 and I square it, what do I get? I would get 9, because this really amounts to 3 squared, which is equal to 9. Okay? Square root of 9 is 3. 3 squared is 9. So when you have the square root of something and then you square it, you get the radicand. So down here, what we have is 7x plus 2 when we square it. So I'm going to show this work, though, because I want to make sure that you all are following along. So what we're going to do is take this here, 7x plus 2, and we're going to square the left side of the equation. And that will be equal to the right side squared as well. What you do to the left, you do to the right. So left side squared equals right side squared. And so on the left then, we simply have the radicand. 7x plus 2 is equal to 16. Take the 2 to the other side like this, and we get 7x is equal to 14, or x is equal to 14 divided by 7, which is 2. There you've got your answer. X equals 2. Okay. So what did we learn in this little problem? We learned that you isolate the term that involves your variable, just like we always do. But in this case, it is a radical. So isolate that radical on one side of the equation, move all your constants to the other side, square both sides to eliminate the radical, and then solve for x. Pretty straightforward. Let's do another one. Example number 2. Okay, is going to be the square root of a plus 11 is equal to 21. Square root of a plus 11 equals 21. This one is even easier because this term is already by itself over here, so we just take the 11 to this side, and then we'll have the square root of a is equal to 21 minus 11. So the square root of a is equal to 10. Okay. So if the square root of a is equal to 10, then how do we solve this? We have to get rid of the radical. How do we eliminate the radical? We square it. Okay, something, square root of something squared is the radicand. So we let me plug in my laptop. Okay, so we're going to square both sides. So the square root of a squared is equal to 10 squared. The square root of a squared is just a equals 100. There you have it, another solution to a relatively easy problem. Moving along now to another example, example number 3. Okay. Example number 3, we have y is equal to the square root of 12 minus y. Y is equal to the square root of 12 minus y. Solve for y. Well, this one already has the radical that involves the variable on the right isolated by itself. So what we're going to do is to square the left and the right. We have to get rid of the radical. Okay, so we square the left and the right, and we get y squared is equal to, this side squared over here is going to be equal to 12 minus y. I skipped a step, but I think you know I squared the square root, right? So I get y squared equals 12 minus y. Bring everything to the left, set equal to 0, factor, complete the square, quadratic formula, whatever seems to be the easiest. So we get y squared plus y minus 12 equals 0. And all we did here, we brought the 12 over here, and we brought the y over here, okay, leaving 0 on the right. Okay. What are the factors of 12? How about 3 and 4? 3 and 4 have a difference of 1. Notice that the center term is 1y, and it's positive. So the bigger of 3 and 4 needs to be the positive term. So what we're going to have here is like this. We're going to have y and y. We're going to have 3. We're going to have 4. We're going to have plus, and we're going to have minus like that, equal to 0. And with this like this, then we know that either one of these terms could be 0. So in the first case, y equals 3, or in the second case, y equals negative 4. Okay. Y equals 3 or y equals negative 4. Now, little bit of a trick here. What can you say about this square root right here? What can we identify about that? So I hope what you notice is that this is a principal square root. When you have just a square root shown, as we have here in this problem, you just have a square root shown, like we do here, where we have square root of 12 minus y. That is the principal square root. We didn't take the square root. It was already shown to us. They didn't put a plus or a minus. They just put plus, right? In other words, it's the positive root, the principal square root, or the non-negative root, maybe is a better way to say it. That non-negative root is equal to y. Notice this side over here. It's equal to y. Can you have a non-negative root equal to a negative number? Think about it. Can a non-negative root equal a negative? Well, that's kind of an oxymoron. Non-negative means non-negative. So what that really boils down to is that this is not a solution. Think about it. If you put -4 in place of y, that means that the square root on the right is equal to a negative. And the square root on the right is the principal square root. They didn't put a plus or a minus in front of it. They only gave us as it is. So this is not an option. Y equals -4 is not an option. Instead, our solution is just this right here. I should just to here, sorry. So y equals 3 is our solution. Now, maybe I should just pause for a little bit and explain again this concept of principal square root, because it tends to confuse a little bit. So the principal square root. What is the principal square root? Principal square root is the non-negative root. The non-negative root. And when you see this symbol, here, square root sign, so long as there's not a plus or a minus in front of it, when it's provided to you in a problem, it just shows up like this. This means the principal square root. When you see this sign by itself just shown to you, then it's the principal square root. So when we solve a problem like this, if we said that x squared was equal to 4, and I tell you to solve for x, we take the square root, all right? So we're going to say that the square root of x squared is equal to plus or minus the square root of 4. Okay, but who took the square root? We did. We're the ones who put the square root there, and we have to account for all possibilities. So it is plus or minus. So x is equal to plus or minus 2. Okay, plus or minus 2. However, if I was to just say this, what is the square root of 4? What would be your answer? In this case, the square root of 4 is only equal to 2, the non-negative square root. And you may say, wait a minute, how's come over here on the right, we have the square root of x squared equals plus or minus the square root of 4, and then x equals plus or minus 2, but the square root of 4 over here on the left is just equal to 2. Don't get too hung up on this. When you see a square root shown to you, like we have here on the left, like this, it means principal square root, the non-negative root. When we solve an equation for x or some other variable, like we have here on the right, we must account for all possibilities. So we have to do the plus or the minus. Now I want you to go back up here to this problem and notice that on the right, we just have a radical sign shown to us. There was no plus or minus put in front of it. Therefore, it must be a positive number. It must be the non-negative root that we're talking about. So y on the left could not be negative because that would mean that this was not the principal square root. So I hope that clears it up just a little bit. Maybe that helps. Hopefully that helps. We're ready for example number 4. So here we go. Let's see if we can find one that's maybe slightly more challenging. 5 times the square root of x minus 3. Okay. Plus 4 equals 14. Okay. Again, your initial job is to isolate this term, take the 4 over there. So we have 5 times the square root of x minus 3 is equal to 14 minus 4 or 10. 14 minus 4 or 10. Now, I could go ahead and square both sides if I wanted, but I would suggest that before I do that, why don't I divide both sides by the coefficient that's out there in front of that radical. This radical is being multiplied by 5. It's 5 square roots of x minus 3. Let us divide both sides by 5 like this, okay? Divide both sides by 5. And when we do that, what do we get? Okay, the 5's cancel on the left, so we get the square root of x minus 3 is equal to 2. Now, this is the principal square root. We square both sides, and we get x minus 3 is equal to 2 squared is 4. Maybe I'm going too fast. I'm skipping a step here. I'll do in blue to show you what I'm trying to do. Okay. Square both sides. So we get the radicand, x minus 3, is equal to 2 squared, or 4. Last step, I take the 3 to the right. Okay, take the 3 over here, and I get x. X is equal to 4 plus 3. X equals 7. X equals 7. Cool. Nice problem. I hope that seems fairly logical to you. Let's move on to example number 5. Example number 5. Okay, the square root of 5x over 6. Square root of 5x over 6 minus 10 is equal to 4. Okay. Once again, what's the procedure? Isolate this term by taking the 10 over here. Okay. Taking the 10 to the right, you isolate the term that has the variable in there, isolate that radical, and square both sides, solve for x. Okay. So after we take the 10 to the right, we will have the square root of 5x over 6 is equal to 4 plus 10 is 14. Okay, 4 plus 10. Add 10 to both sides. So 4 plus 10 is 14. Now I square the left and I square the right. What do we come up with here? When I square the left, I will get, and I'll show this step to make sure we're all together, 5x over 6 quantity squared is equal to 14 quantity squared. On the left, we just get the radicand, which is 5x over 6 is equal to 14 times 14, which is, so 14 squared is equal to 196. So now we multiply by the reciprocal of the left and of the coefficient of x, which is on the left here. 5 over 6. What's the reciprocal of 5 over 6? 6 over 5. So we're going to take and we're going to multiply by 6 over 5 on both sides. 196 times, parentheses, 6 over 5, like that. Both sides times 6 over 5. So what happens on the left? Well, works out pretty nice for us. These cancel, and we're just left with plain old x equals. On the right, how many times does 5 go into that? Well, it doesn't go in evenly. 10 would go into there, 19.6. 5 would go in twice that, which would be like 39.2 or something like that. And then we multiply by 6. So this is going to come out to be a decimal number. It's not going to work out cleanly as a clean fraction. It's going to be a little strange. So I would accept a decimal answer for this problem. The fraction is going to be quite large and unruly if we did not. So what is this thing then? 196 times 6 is equal to 1,176. So this could be written as 1,176 divided by 5, which is going to be equal to 235.2. Okay, 235.2. Sorry here, my little stylus pen is not working very good. It's messing up on me. 235.2. There. Okay, that's x. So that is your answer. 235.2. Okay, we are ready now for example number 6. And this one has some new things that we need to take note of. I hope we can make it clear because it involves the whole concept of principal square root. So this problem is as follows. The square root of x squared plus 9x plus 15 is equal to x plus 5. Notice that the left side of our equation, x squared plus 9x plus 15, is the radicand. In other words, it's what's inside the radical. This represents a principal square root because there is no plus or minus in front of it. We didn't write down the square root, this square root. We didn't take the square root of both sides. If we had, we'd have to use plus or minus. But in this case, it's given to us as the principal square root. So just bear that in mind as we move forward. And let's see if we can't make sense out of this. So squaring both sides now, we get the radicand, which is what's inside, x squared plus 9x plus 15 is equal to x plus 5 quantity squared. So I squared the left and I squared the right. Okay, when you square the left, you get what's inside. So this stuff over here squared is equal to this stuff over here squared. Okay, that's what we did. So the left side squared is just the radicand, right side squared is x plus 5 quantity squared. Now, I think you remember that when you have a plus b quantity squared, it's equal to a squared plus 2ab plus b squared. So x plus 5 quantity squared is x squared plus 2ab. A is 1, b is 5. So 2 times 1 times 5 is 10. So this is going to be x squared plus 10x plus 25. Let's get our terms collected now, but first we can do some simplification. I want you to notice that we have an x squared on the left and on the right. If I subtract x squared from the left and from the right, notice what happens here. They cancel out. They cancel out. And when they cancel out, it leaves us with a simpler expression. We now have 9x plus 15 is equal to 10x plus 25. So on the left then, if I bring my 10x over here and I bring my 15 over here, we will have 9x minus 10x is equal to 25 minus 15. And 9x minus 10x is minus x. Over here we have 10, or x is equal to negative 10. Okay, x equals negative 10. So we've come up with a possible solution, maybe, for x. X equals negative 10. But let's go back up here to the top and let us notice that this guy right here is a principal square root. That means it is the non-negative root. The non-negative root. Okay? And so since it's the non-negative root, what it means is that it cannot be equal to a negative on the right. So what is x plus 5 on the right? Let's just go back here and study this thing out a little bit. If we have the square root, this square root over here on the left of x squared plus 9x plus 15 equals to x plus 5. If I plug in my value of x here, it's negative 10, right? Okay. On the right side, or sorry, on the left side, what do we have? It would be the square root of x squared, that's negative 10 squared, plus negative 10 times 9 plus 15. So this thing simplifies down a little bit. What's negative 10 squared? It's 100. Okay. Minus 90 plus 15 is equal to, on the right, minus 5. Okay. So you look at the left side and you say, well, 100 minus 90 is 10 plus 15 is equal to 25. So we have the square root of 25. Does that equal negative 5? Does it equal negative 5? Well, the answer is that no, it does not equal negative 5, because what's on the left is the principal square root, the principal square root. And the principal square roots are non-negative square roots, okay? So the non-negative root of 25 is just 5, and 5, we can see, is not equal to negative 5. So we have to conclude the following. We have to conclude that this problem has no solution. Okay, no solution, because 5 cannot be equal to negative 5. Now, how would you know this really? You would know it because you recognize that right up here at the top, what's on the left is the principal square root of x squared plus 9x plus 15. And you work that on down here, and you get the principal square root of 25 is 5, not negative 5. So I hope that clears things up a little bit. So that is example number 6. And I think you'll like example number 7. It kind of takes us to a topic that's coming up, although I think you know this. Do you guys know the Pythagorean theorem? You know the Pythagorean theorem? Have you seen it before? If you have a triangle, a right triangle, okay, did you know that if this side is A, and this side is B, and this side is C, okay, that there's a special relationship that exists between A, B, and C, and it's expressed by the Pythagorean theorem. coming up in the next section, I believe, but we keep bumping into it from time to time in our algebra class, and it's definitely in your geometry to come. So remember, short repetitive exposures. Let's see this thing, soak it in. Pythagorean theorem says that the sum of the squares of the two legs is equal to the square of the hypotenuse. Which side is the longest side on this triangle? The longest side is always opposite the 90. Always opposite the 90-degree angle. This down here is the 90-degree angle. And so the longest side is this one over here. It's the one opposite the 90. And so here we go. This is the Pythagorean theorem. It says that a squared plus b squared equals c squared. Simple enough. A squared plus b squared equals c squared. C is the hypotenuse, okay? I'm not sure if I spelled hypotenuse right, but anyway, hypotenuse, okay? So the hypotenuse is the longest side. It's opposite, always opposite the 90-degree angle. By the way, if there's no 90-degree angle, there's also no hypotenuse, right? The hypotenuse only applies to right triangles. So, and this Pythagorean theorem, this guy right here, only applies to only applies to right triangles. So this guy over here is called the Pythagorean theorem. Pythagorean theorem. A squared plus b squared equals c squared, where c is the hypotenuse and a and b are the other two legs of the triangle. Now, all right, here comes the problem. Let's see if you can handle this one. Let us do the following. I want you to find b. So here's the question. If c is equal to 6 and a is equal to 3, please find b. Find b. Okay. Well, a squared plus b squared equals c squared. So here we go. 3 squared plus b squared is equal to c squared. How's it looking? A squared plus b squared equals c squared. A is 3, so 3 squared. Okay. 3 squared plus b squared equals c squared, and c is 6. Why did I put cubed? I have no idea. Guys, this is a squared. 6 squared, okay? Now, let's solve this thing for b. How do we solve for b? Well, we take that over there to isolate the b term. So we get b squared is equal to 6 squared minus 3 squared, okay? Which comes up to be equal to 36 minus 9. What is 36 minus 9? Okay. B squared is equal to 27. Now, we're ready to take the square root. So we take the square root of the left and the square root of the right. So b is equal to the square root of 27. Uh-oh. Did you just think plus or minus? Did you just think plus or minus the square root of 27? I hope you did, because that would be the standard approach. We would say plus or minus the square root of 27. However, we are dealing with a triangle, aren't we? Triangles have sides which are always positive because we're measuring lengths. Lengths are not negative. So we reject the negative root and we only deal with the positive root. So b is equal to the square root of 27. The principal square root of 27 here is what we're after. And how do we simplify that? It's not in simple form because the radicand has factors, one of which has a nice square root. This can be written as the square root of 9 times 3. Okay? And I believe that you remember from our other section that this is the square root of 9 times the square root of 3, which is equal to 3 square roots of 3. Okay? B is equal to 3 square roots of 3. Cool. There's your answer, 3 square roots of 3. Now, this is a very special right triangle that we're dealing with. When you have a triangle, it's a right triangle where you have sides in this relationship, it's a special one. And let me just write it down here for you. So if this is 3, this will be 6, and this will be 3 times the square root of 3. Okay? 3, 6, 3 square roots of 3. It's a special one. And how can I explain this to you here? This one, this angle down here is 60 degrees. This angle up here is 30 degrees. Okay? It's a 30, 60, 90. 30, 60, 90 triangles always have sides. By the way, this is short repetitive exposures. Short repetitive exposures. You don't have to be responsible for this. I'm not going to give it to you on a test, but they are always like this. If this is L, this side will be 2 times L, and this side will be L times the square root of 3. L, 2L, L square roots of 3. When we have a 30, 60 right triangle. Okay? L, 2L, L square roots of 3. So, with that said, if you come back up here to my problem, where we first gave you the sides, I told you that C was equal to what? Get a different color here. I told you that C was equal to, my stylus is kicking out on me again. I told you that C was equal to 6. I told you A was equal to 3. See the relationship? 3, that's L. 3 times 2, 6. What's this side over here? 3 square roots of 3. You could have just written down the answer had you known this little cool fact. 3, 6, 3 square roots of 3. Okay, L, 2L, L square roots of 3. L square roots of 3 is the other leg. Okay, hypotenuse is always the longest. All right, well, enough said. I hope that provided you with some inspiration for your assignment. And that brings us now to the conclusion of this lesson. I hope that you've enjoyed it, and I will switch back over here and tell you guys goodbye. All right, if you have questions, call me. You know, I don't get much feedback from you. You guys are not calling me a lot. You're not sending me many questions, so I presume that that means you're all good. You're doing well, and you're achieving what you need to achieve. I'm not going terribly fast, trying to keep the pressure off a little bit. I know you guys have lots of classes, and some of the others are pretty tough, I'm guessing, from what I'm hearing. So good luck to you. Do your best. Just because we're not cruising along at breakneck speed, you know, just because we're not going super fast, please do not relax too much, okay? Do not relax too much. Study, do your math, and you'll do well. I'm confident. If you watch this little lecture, do the examples, pay special attention to that concept of principal square root because it'll trip you up. And we will move ahead to next section next time, and do your assignment, and good luck to you. We hope to get pretty deep, if not through, most of chapter 11 before we finish school up on June the 19th. Will be our final day. It'll be the final exam day. So I'll be thinking along those lines. We're going to have 2 more tests before this is over. So there's still quite a bit of opportunity to change your grade, so work hard, okay? Best of wishes to each of you.